Then we have our, yeah, we need some humor a bit, okay? Then the table will change a bit because it's good practice that we put the material. So we know section 1 is aluminum, the rest is Kepler. Okay. Then we put our N value. We know this is 1, right? Then the rest, the N is 1.792. Because they're Kevlar. And we pick our reference material as aluminum. Okay. Then the next one, we need to include our N, width, and depth. Okay. We need to include our N, width, and depth. Right. Before we do that, I was halfway doing this while we got interrupted. This is our Y, and this is our Z. Okay. So what we are going to find out regarding the second moment of area, we are interested in the ZZ axis. So this is our ZZ axis. Our analysis for today, we're going to start from the top as our reference, and we want to find what is our Y bar. Okay, so the datum is from the top. Then we carry on. Our N is 1. For the aluminum, the width is 12. The depth is 0.5. So this is equal to 6. 2 and 3 are the same. N is 1.792. The width is 0.5. The depth is 6. Okay, so this will be equal to 1.792 times 0.5 times 6 is 5.376. Same thing. 2 and 3 are the same. Let me do it again. 1.792 times 0.5 times 6. Yep. And then the last one, okay, 1.792. The width is 12. The depth is 0.5. So 1.792 times 12 times 0.5 is 10.752. 1.792 times 12 times 0.5. Yep, 10.752. Then after that, we determine our local Y bar or member Y bar, small Y bar. Yes. The what should be 1? It should be 12 because 12, if you look at the diagram, 12 is from here to here.
Right, but didn't you divide it? So the whole.
I don't see why it should be 11.
So for 2 and 3.
It's 6. Hold on, I have a question. So 6 is from the top to the bottom.
Right, I understand that. But didn't you?
The width is the inside is 12, not the outside.
Inside. Okay, sorry, I didn't see that.
Okay. Okay. It's okay. I'm getting old also. Sometimes I miss stuff. Okay. So the y bar is 0.5 divided by 2. So this is datum at the top. Then it's 6 divided by 2, 3. Then the last one is 6 minus by 0.5 divided by 2. Okay. So it's 5.75. Okay, that is 5.7. I have a question online. Okay, never mind. Okay. Then from here, we can determine our n and our y bar. Okay, so 6 multiplied by 0.25, 1.5, 5.3376 multiplied by 3, 16.128. Let me do it again. 5.376 multiplied by 3, 16.128 is correct. And then it's 10.752 multiplied by 5.75 is equal to 61.824. I'll do it again. 10.752 multiplied by 0.75, 61.824. Then we sum everything up together. $27.504. And the other side, $95.58. So then we determine our global centroid, which is equal to 95.58 divided by 27.504. Okay, so 95.58, 27.504, we divide them. It's 3.475 inches from the top. Okay, 3.475 from the top. Or, okay, so 3.475 minus 6, 2.525 from bottom. Okay. So the next thing we're going to do, we're going to calculate our second moment of area. Okay. So it's like if you form the table like this, like what I teach you, is so easy. I realize some of you in your term test, you just ignore it and you do it your way. Sometimes you get it right. Sometimes you get it wrong. This way of doing it is more organized. You decide, okay? There's more than one way to eat a hamburger. IZZ1. So let me write out the formula first, okay? So IZZ is equal, because it's sandwich material, it's NW DQ 12 plus by NW multiplied by D big Y bar minus small y bar squared. Okay, so that's the formula that we are going to apply. Okay, so we are going to do IZZ1 will be equal to 1, 12, the depth is 0.5 cube over 12 plus by 6 multiply by 3.475 minus by 0.25 squared. Okay, so this will be equal to 1 times 12 times 0.5 power 3 divided by 12 plus 6 times by 3.475 minus 0.25 close bracket square is equal to 62.529 inches to power of 4. Okay. Then we do IZZ2, which is equal to IZZ3. So this is equal to 1.792 multiplied by 0.5, 6 cubed over 12 plus by 5.376, 3.475, bracket 3.475, minus by 3 squared. I get 17.341. And finally, IZZ4 12 plus by the area is 10.752 times by 5.75, oh no, 3.475 minus by 5.75 squared. Okay. I got 55.872. Okay. So once you got this value, you find your IZZ, which is equal to 65.529 plus by twice, okay, of 17.341 and plus 55.872. So 65.529 plus 2 times 17.341 plus 55.872, 156.083. Inches to power 4. Okay. So once you get this, it's time to apply it's time to determine the stresses. Okay. So I'll let you guys copy. Anyone, any question, either face to face or online? Anyone? Yes. Because I select it to be 1. You decide, like what I mentioned earlier, you decide what you want the reference material to be. For this case, we choose aluminum. Okay, you can choose Kepler. The answer will be exactly the same. Okay. Right. So I don't hear any other questions. So now let me copy this image. Okay. Let me string the size of the image. Right. So the question asks us for the maximum stress of the aluminum and the maximum stress of the Kevlar. So I think I'm going to sorry, don't mean to give you guys headache. I will. Hey, come on. So now Okay, we know the distance of the y bar, right? The distance of the y bar is slightly lower. Okay,